Hey guys, Professor Calculus is here, and today in this video we're gonna see how we should solve this integral. Before that, make sure to like and subscribe as it is free and you can always change your mind later. So I'm gonna go and, like always, define a parameter t and say that my integral is equal to cosine of tx minus cosine x over x squared, so it's supposed to be x squared, dx. And if I differentiate it, I'm gonna get partial derivative with respect to t of the integral of cosine of tx minus cosine of x over x squared dx. And I prime of t is gonna be becoming, this is gonna go away. This is gonna go, this is gonna go away because we're differentiating with respect to t, and this is constant. This is also constant, so I'm gonna get negative sine of xt times x over x squared dx, and these two are gonna go away, and it's gonna give me I prime of t, the integral from 0 to infinity of sine of xt over x dx. And from the standard Dirichlet's integral, we can find out that this is indeed equal to negative pi over 2. Now if I integrate both sides, so I'm gonna integrate both sides, I prime of t dt equals to negative pi over 2 dt, and I of t is gonna be negative pi over 2 t plus c. Now my I of t was the integral from 0 to infinity of cosine of tx minus cosine x over x squared dx, which is c minus pi over 2t. And if I let t be equal to 0, this is going to go away. Cosine is going to be 0. Cosine of 0 is going to be 1. Thus, I'm going to get cosine of 0 is 1, and I'm going to get 1 minus cosine x over x squared dx, which is equal to c. Now, I need to solve the integral of from 0 to infinity 1 minus cosine x over x squared dx. Now I'm going to define c of a, which is going to be 1 minus cosine ax over x squared, and my objective for finding this constant, which is c of 1, is to find this integral using Feynman's trick of integration again. Now my c prime of a is going to be, again, partial a of sine of ax over xx. This is gonna go away. C prime of a is sine of ax over x dx, and from the standard integral result, we're gonna again say this is equal to pi over 2 plus c, and pi over 2, and integrating it gives c of a equal to pi over 2t plus c, and letting a be equal to 0 gives me again c equals 0. Thus c of 1 equals pi over 2. I did this part so fast because it was just reusing the same trick, Feynman's trick again. And I find out that I of t is c of a minus pi over 2 t, which is, c of 1, which is pi over 2 t minus pi over 2, which is pi times t minus 1 over 2, which is I of t. And we were looking for I of pi, if you remember, and I of pi would be the integral from 0 to infinity of cosine pi x minus cosine x over x squared dx is pi minus 1 over 2. And thus we conclude that our integral from 0 to infinity of cosine pi x minus cosine of x over x squared dx is pi times pi minus 1 over 2, and that is the final form of our integral. Thank you for watching this video. Please like and subscribe if you enjoyed, and I'll see you next video.